Good evening, geometry students. I hope everybody's doing well. We are in section 6-6, and we are talking about properties of kites and trapezoids. So what I'd like for you to be able to do by the end of this lesson is to verify and use properties of kites and trapezoids in order to solve for missing values. So let's jump in with just some definitions as well as properties, because once we get those properties listed out, then we can more easily apply them. So first of all, what is a trapezoid? Well, a trapezoid is going to be a quadrilateral with one pair of parallel sides. So notice it just has one pair. Now it's going to have a couple properties as well. It's going to have this thing called a mid-segment, and that mid-segment is going to be parallel to both of the bases. So the mid-segment is parallel to both of the bases. And the length of the mid-segment is the average of the two bases. Now, what do we mean by bases? Well, if we were to just draw a trapezoid out here to the side real fast, the bases would be the two sides that are parallel to each other. So this guy and that guy would be the bases. Now we have a special type of trapezoid called an isosceles trapezoid. An isosceles trapezoid is going to have a pair of legs that are congruent. So a trapezoid with two congruent legs. Now, because it has two legs that are congruent, that's going to cause more properties for this specific type of trapezoid. To begin with, the diagonals are going to be congruent, and the base angles are congruent as well. We have one more type of shape that we're going to talk about in this set of notes, and that's something called a kite. Now, a kite is a quadrilateral with two pairs of consecutive sides that are congruent. So it's a quadrilateral with two pair of congruent consecutive sides. Remember, consecutive means that one side follows after the next in the shape. So if I were to draw a quick image of a kite, it would look something kind of like that, to where this side is congruent to that one and this side is congruent to this one. Okay. Now, this guy is going to have a couple properties as well. The diagonals of kites are perpendicular. And there are no parallel sides. Alrighty. So, let's just start applying some of these formulas, or I'll say properties of these shapes. So it says in example one, it says ABCD is an isosceles trapezoid. The measure of angle A is 102, so I'm going to go ahead and label that. What are the measures of angles B, C, and D? Okay. So what I need to focus on right now is the fact that this is an isosceles trapezoid. So we might need to go back up here and remember some things we know about trapezoids. We know diagonals are congruent as well as base angles are congruent. So base angles are the pairs of angles on either base. So that means that this angle is going to be congruent to that one. And I also know these opposite sides are congruent because it's an isosceles triangle. And then I know that this angle is going to be congruent to that one. So I can easily figure out what angle B is. Angle B is going to be 102 degrees. So I'll go ahead and label that. Angle B is equal to 102 degrees. Because these pair of base angles have to be the same. Now, in addition, I know that this is a quadrilateral, so it has 4 sides and it has 4 angles, which means the 4 angles add up to 360 degrees. You might use your n minus 2 times 180 formula to calculate that, or you might have it memorized. So I know if I were to call this angle x and this angle x, I would need these two plus these two to add up to 360. So I'm going to do that. So 102 plus 102 is 204, plus 2x is equal to 360. Okay, now I'm going to subtract 204 from both sides, getting me 2x is equal to 156. And then I divide by 2 on either side, and that is going to get me 78 degrees. So now if x is equal to 78 degrees, then that means this base angle and this base angle are both 78 degrees. So I'm going to say angle C is equal to 78 degrees and angle D is equal to 78 degrees. The reason I know that one more time is because the 4 angles in a quadrilateral have to add up to 360 degrees, but also I know that the 2 pairs of base angles are going to be congruent to each other. Alrighty. Looking at example 2, it says KB is equal to 21.9 and MF is equal to 32.7. Find FB. What property did you use? We first need to identify what type of shape this is. So we have 1 pair of parallel sides. So I'm going to highlight that part for you. These arrows are meaning parallel. So I've got 1 pair of parallel sides, so this is a trapezoid. But not only that, we have these markers right here indicating that these sides are going to be congruent to each other. So I have an isosceles trapezoid. Because this is an isosceles trapezoid, let's look at my properties. I know that diagonals are congruent for an isosceles trapezoid. So when I'm working through this problem, I now know, okay, from K to B, which is from here to here, is going to be 21.9. And then the whole distance from M to F is 32.7, the whole thing. So if this entire distance is the same as this entire distance, meaning the 2 diagonals are the same length, then to figure out the remaining, which would be FB, I would be able to take 32 minus 21.9 just to get that last remaining part. So I'm going to take 32.7 minus 21.9, and when I do that, I'm going to get 10.8 is equal to FB. And then it says, what property did we use? Well, we used the fact that diagonals of an isosceles trapezoid are congruent. Diagonals are congruent of an isosceles trapezoid. There we go. Flipping that page over, in example 3, it says in kite ABCD, the measure of angle DAB is equal to 54 degrees. So I'm going to do that first, DAB. So this whole thing is equal to 54 degrees. And the measure of angle CDF is equal to 52 degrees. So CDF is equal to 52 degrees. Cool. We want to figure out what the measure of angle BDC is, and so on and so forth. So measure of angle BDC, which is did I label this wrong? CDF. Okay, so BDC. That is actually the same angle. So CDF is this angle right here. But then when I look at BDC, from B to D to C is also just 52 degrees. It's the same angle. So I'm going to say that's 52 degrees. Then I want to know what ABC is. So from A to B to C. So I do know, just based off of what the definition of a kite is, I know that like this guy is congruent to that guy and this guy is congruent to this guy. And then this line right here is congruent to itself. So if I look at this as a left and right side of this kite, I know that the top side is going to be congruent to the bottom side, or the left is congruent to the right. So what I can do is say, okay, well, if I know that this is like a mirror of each other, then up here must be 52 degrees. And then I also have this 90-degree angle right here because the lines are intersecting at a 90-degree angle. And I then need to see if I can figure out what this missing value is right here. So what I'm going to need to do is kind of, I need to figure out what these three angles add up to in this triangle. So I know that there's a 90-degree angle right here. And then I also know that this angle is being cut in half because this side of the shape is the same as the upper side of the shape. So half of 54 is going to be 27. So I'm going to put that 27 in here for you guys as well. So up here is 27 and down here is 27 degrees. Okay, so now if I know this angle plus this angle plus this angle need to add to 180, then I can just take 27 plus 90, which is going to equal 117. And then if I were to take that from 180, then I'm going to get 63 degrees. So now I know that this degree right here is 63 degrees. And I'm just double checking myself putting it in the calculator. Good. Okay, so now if I know that this half of ABC is 63 and this part is 52, I can just add those two things together. So I can say 63 plus 52 is going to equal 115. And there we go. Finally, I want to find the measure of FDA, which is from here to here. So this one shouldn't be too tough because we know that the left and right sides are once again symmetrical to each other. So this guy has to be 63 degrees. Alrighty. Looking at example 4, it says ABC is an isosceles triangle. What are the values of x and y given that DE is parallel to BC? Okay. So first of all, I've got an isosceles triangle going on here. So that means that this whole side is congruent to this whole side. And if this line is parallel to this guy, then that means that these transversals are being cut proportionally. So what we can do is we can figure out what one pair of angles is because they're base angles of an isosceles triangle, and then use the fact that we know what a line adds up to and things like that. So here's what we're going to do. I know that this great big triangle right here, ABC, is an isosceles triangle. So that means this angle and this angle are congruent to each other. But if I'm focusing in on the biggest triangle, I'll try to box it in for you. I'm focusing on the biggest one. I know that these three angles have to add up to 180 degrees. So this angle is y and this angle is y. Alrighty, so I can say 32 plus y is equal to 180. So 32 plus y is equal to 180. So 32 plus 2y is equal to 180. I'm going to subtract 32 from both sides, getting me 148. So 2y is equal to 148. Divide by 2 on both sides. Y is going to equal 74 degrees. Okay, I know what y is now. Now, there's a couple ways you can consider this. It's up to you. One way that you can consider is focusing in on this isosceles trapezoid again. You're absolutely allowed to do that, and then that would be pretty much just like this example right here where we said, okay, these two are the same and these two are the same, subtracted from 360 and divide by 2. You can also say, okay, I've got a pair of parallel lines here because it told us in our problem. So if those lines are parallel, then that means that corresponding angles are congruent. So this y is corresponding to this angle up here, which is 74 degrees. So now angle x and this 74 are forming a straight line, and I can just take 180 minus 74. So that's what I'm going to do. I'm going to take 180 minus 74, and that is going to get me 106 degrees is equal to x. Like I said, there's more than one way to solve that one. That's kind of up to you how you want to break the image down. We just have one more example and then we're done with today's notes. So in example 5, it says, the given quadrilateral is an isosceles trapezoid. What is the length of its mid-segment? Okay, so it really doesn't matter if they're isosceles or not, and they actually do not look like they are isosceles at all, so let's just kind of ignore that for right now. The mid-segment of a trapezoid is just going to be the average of its two bases. So if I'm trying to figure out the middle length of these trapezoids, I'm going to take the two bases, add them up, and divide by 2. It's this formula, essentially. So let's do that. So I'm going to say 13.5 plus 8 divided by 2 is going to equal the midpoint, or the mid-segment, I apologize. So 13.5 plus 8 is going to be 21.5. So now I've got 21.5 over 2 is equal to the mid-segment. Divide that by 2, and I'm going to get 10.75 is equal to the mid-segment. Now over here, I meant solve for x because we already know what the mid-segment is. We want to solve for x. So we're still using the same formula. The first base plus the second base over 2 is equal to the mid-segment. So there's my formula. So I'm going to say x plus 3 plus 4x plus 7 over 2 is equal to 15. So base 1, which is x plus 3, plus base 2, which is 4x plus 7, over 2 is equal to the mid-segment, which is 15. So now I'm going to start solving. Combine like terms in the top of your fraction. So that's going to be 5x plus 10 over 2 is equal to 15. Now I want to get rid of this 2, so I'm going to multiply by 2 on both sides. That's getting me 5x plus 10 is equal to 30. I'm beginning to run out of space, but I'm going to subtract 10 from both sides. That's going to get me, I'll just go over here. That's getting me 5x is equal to 20. Divide by 5. X is equal to 4 for my final answer. We will be practicing with this formula tomorrow, so if you're kind of struggling with that, don't worry. We will iron out those details later. But for now, I hope you have a great evening and bring your questions to me in class. Bye.